Hello dear engineers. First I want to thank organizer for inviting me. My name is Said Mohammad Hussein Musavi from Tehran, Iran, and I'm presenting nature-inspired DMU selection and evaluation in data envelopment analysis. Introduction section. In order to have best efficient frontier, it is needed to have closer efficiency value from most of decision management units in data envelopment analysis or DEA. So selecting best DMUs for business in management before running it has high of importance. Also having best DMUs push the business to the ideal point in the data space. Obviously, the closer features or DMUs to ideal point, the more efficient the system is. Nature-inspired optimization algorithm gained the most optimization approach based on natural selection, which differentiates them from the other unintelligent mathematical selection models. Here, biogeography-based optimization or BBO algorithm is employed to select the best features or DMUs, this is the main significance of this research. The system evaluates with four common DEA methods of Charles Cooper and Rudess or CCR, input-oriented banker, James and Cooper or IOBCC, output-oriented BCC or OOBCC, and additive method. The purpose approach compares with original DEA model, mathematical lasso, and other nature-inspired methods such as GA and PSO for evaluation. Written result depicts more efficient values in most cases belongs to proposed nature-inspired DEA method. Also, in order to present more comparisons, another optimization, which is Firefly algorithm fuzzy regression, is used for final linear regression part. If a regression represents more correlation coefficient compared to traditional regression methods, average value of 0.914 is returned for all ranks and all database and for all DEA methods after the proposed feature selection method. Additionally, average correlation coefficient of 0.945 and MSE of 0.132 are returned by fuzzy Firefly regression method for all datasets and ranks. Businesses and companies are looking for best ways to increase their facility productivity and efficiency in data envelopment analysis by various factors. In management, these factors called decision management units or DMUs. Considering the efficiency of a hospital, for an example, DMUs are number of doctors, number of nurses, and number of patients. As input features and treatment per day, there are features and treatment per day are output. Total efficiency could be calculated based on having this data. For instance, if number of doctors is 10, number of nurses is 20, and number of patients is 50, this is more efficient than if we have 15 doctors, 27 nurses, and 25 patients. As with less resource, more patients are cured. So selecting these DMUs wisely are so crucial to have the most efficient business experience. To do so, a number of techniques and algorithms are proposed by different researchers during years. Most of them use all traditional feature selection methods, and some of them use these algorithms for other purposes of DEA, which are limitation. Here, DMUs or features are selecting based on nature intelligent, which is called nature-inspired or bio-inspired algorithm, which is the main objective of this research. We use biogeography or BBO algorithm, as I mentioned earlier. BBO is faster than other optimization algorithms and return more optimized result in less iterations. This leads to select best DMUs with higher values and closer to 1 for business. Basically, BBO feature selection removes any weak DMUs which may result low value efficiency and DEA. Furthermore, by increasing number of samples, for example 100, and number of DMUs for features to, for example 10, selecting best DMUs is a laborious task. So when dealing with big data sets, removing some of the weak samples is so rational. The main goal is to select those DMUs which are closer to efficient frontier. Literature section. Feature selection or dimensional reduction is a vital task in data mining and big data. It is done by decreasing number of features and selecting best ones. By doing that, not only processing speed increases, but also outliers which are less desirable eliminates from the main process. Principal component analysis or PCA is one of the most effective but traditional feature selection in data mining. Another more advanced feature selection algorithm is called lasso regularization, which is more time consuming but ends up with more effective with features than PCA. Another interesting feature selection is based on DEA research, belongs to Zhang and Yishi and partners, in which they did something in reverse of this research purpose. Actually, they used the DEA of each DMU as their final feature selection factor, in which those DMUs with higher DEA value got selected as features. Among nature-inspired algorithms, PSO feature selection and genetic feature selection are two of the best. Nature-inspired technique always return more impactful feature but gain more complexity too. Proposed BBA feature selection for DMU would be compared with all these four mentioned algorithms in validation section. Proposed method and evaluation section. Clearly, DMUs in DEA define system performance, and in small businesses, DMUs values could be determined easily. However, in a big businesses or in dealing with real big data, things are different. Any mathematical implementation of nature could handle certain number of mathematical problems. One of the nature-inspired algorithms is VBU, as I mentioned, which we intended to use it for feature selection or DMU selection in DEA. Based on multiple experiments and different algorithms, BBU algorithm is selected as it returns more optimized value in faster runtime. Here, each DMU is considered as a feature in a feature space, which makes our final feature matrix for the main purpose. After feature selection by BBU algorithm, efficiency and DEA calculation begins, and leads to nonlinear fuzzy far-field regression algorithm, which is another bio-inspired algorithm. Based on multiple experiments, nature-inspired regression algorithm return higher correlation coefficient than other traditional algorithms and methods. Far-field algorithm showed the best performance among all, which is considered for this part. Here we can see workflow of the proposed method. At top we can see top left starts with datasets and DMU features. They are going to be feature selection. Some of the feature eliminates, some of remains. Then it goes to the bottom left for DEA and calculating efficient frontier. Then it goes for the final analysis for inside far-field fuzzy regression. BBU feature selection. BBU algorithm is consists of important parameters of number of habitants or human suitability index or HIS, immigration rate or mu, immigration rate or lambda, suitability index variance or SIV. The algorithm is all about moving living creatures from one habitat to another with better life condition and room to grow. In feature selection, we are dealing with number of features, NF, weight of features, W, and mean square or MSE, which should be minimized to select those features. Also, if xi are values of a number of features, then xi hat would be selected features out of number of features. So considering number of features entering the system, y would be the output and t would be the target. In order to calculate final error, ei need to be calculated, which is ti minus yi. So final error is minimized of MSE as follow. This goes for all features, and finally those features with lowest MSE will be selected. In combination of BBO and feature selection, each feature vector or DMU is considered as an habitat with different HIS. Those habitats which could fit into final iteration would be selected alongside with their related features with lowest error. Here we can see the pseudocode of BBU feature selection as I mentioned earlier. Data envelopment analysis or DEA, originally introduced by Charles and Cooper in 1978 based on Ferrell idea in 1957. DEA faced multiple forms of it by different researchers around the world, but it's still one of the most flexible tools in various areas, specifically in management. DEA employs to evaluate the performance of different kinds of entities in various range of activities and applications. DEA main target is to estimate the system efficiency by different input and output factors, which leads to select best DMU for having the most efficient system. Evaluation takes place with 4 common DEA methods, as I mentioned earlier: CCR, IOBCC, OOBCC, and additive. CCR model measures the overall technical efficiency. BCC model assesses the pure technical efficiency. CCR model has a straight line efficiency frontier, and BCC model has a convex line efficiency frontier. As we can see here, for input and targets and a few features, as we can see as a circle, we have BCC and CCR models, and their shapes are vivid here. Firefly fuzzy regression. Firefly algorithm is one of the most robust and famous nature-inspired optimization algorithms. It has proper application in learning for regression tasks. Now, this regression could be aided with other clustering techniques as input data. Here, fuzzy C-means or FCM is used. Fuzzy C-means is the fuzzy model of K-means or load clustering algorithm. By clustering the data in initial steps, data will be organized in an optimized manner for training step. Clearly, more cluster means more accuracy, but brings more computational time and complexity. The goal here is to adjusting base fuzzy parameter according to modeling error by FA and returning best fuzzy parameter values as the final result. So, initial fuzzy model creates by defining number of clusters. FA is considered a 5 main part of number of population, which are fireflies or X, light intensity of each firefly or I, light absorption coefficient or gamma, attraction coefficient or beta, and also mu or mutation rate. It simply works by moving toward moving lower light intensity fireflies toward higher ones, effective mutation, and updating old and new solutions. Basic FCM model will be transformed to a better fuzzy model after taking effect by FA on its membership function and parameters. By evaluating a fuzzy FA model using fuzzy inference engine, final train data which train and test is available. In order to calculate error, fuzzy data should return to its original crisp model, which this action is called defuzzification. Clearly, inputs are train and test and test inputs, and evaluated version of them are train and test outputs. The difference between train and test output and train and test target provides system error, which here are MSC, RMSC, mean error, and STD error. Here we can see the pseudocode of fuzzy firefly regression algorithm. Also here we can see firefly algorithm and BBO algorithm parameters which are used for the experiment on datasets, number of iteration, population, and more. Also here we can see the datasets which are used. From left column we can see the name of the datasets: clickstream data for online shopping, daily demand forecasting orders, online news popularity, and stat log. Name of datasets. We have their areas, we have their associated task, we have their instance, number of samples, and also number of features which we are going to select based off those. Here we can see testing bar plot of BBO feature selection on samples of daily demand forecasting order datasets versus DEA on original data. Here we can see at top 7 features, all of the features, and bottom 8 features and 10 features. Clearly, DEA value is going to be reduced after reducing number of features to 7. That means less features, less than 7, is going to harm the result. Also here we can see BBO algorithm training stage for feature selection over 1,000 iteration in one of the experiments. Here we can see average of CCR, IOBCC, or OBCC and additive methods on datasets, and comparison with other methods in 3 ranks. Clearly, from left to right, we have features, amount of them as a rank. Then we have each column of each dataset, and the result of each rank, which are 75%, 57%, and 25% of the features. BBO features on DEA achieve best result among all. Then we have PSO in the second place. Then we have original data. Then we have genetic features, and finally loss of features on DEA. Here we can see comparison of different methods as a box plot. X-axis presents datasets, and y-axis presents DEA value for GA, PSO, LASSO, and BBO. Here we can see fuzzy farfel nonlinear regression test on samples of online news popularity dataset after BBO feature selection by rank number 1 or 25%. Left figure shows the farfel train, fuzzy farfel train, and right fuzzy farfel test, and their related correlation coefficient value after the experiment. Also here we can see MSE, RMSE, error mean, and error STD for a regression experiment on the same dataset as train and test. Left column is train, right column is test. As we can see, target and outputs are so close to each other after the experiment, which is a good sign. Here we can see farfel algorithm training for regression stage over 1,000 iterations for one of the experiments. Here we can see CC and correlation coefficient and mean square error comparison for fuzzy regression and fuzzy farfel regression in 3 ranks of features on 4 datasets. By looking at the results, performance of the loss of regularization DEA meets the modest. However, original DEA on all data have achieved medium performance. GA DEA show a little bit better performance than original DEA in all ranks. Second place goes to PSO DEA, and best result belongs to BBO DEA. Average value of 0.914 is returned for all ranks and all datasets, and for all DEA methods after the proposed feature selection method. Additionally, average correlation coefficient of 0.945 and average MSE of 0.132 are returned by fuzzy farfel regression method for all datasets and ranks, which is significant. Conclusion section. By empowering DEA with nature-inspired algorithm, it is possible to achieve more efficient results compared to using traditional DEA. Nature-inspired feature selection, here BBO, could remove more inefficient DMUs rather than mathematical PCA or LASSO. Furthermore, to have better understanding of rationale between variables of DMU selection and nature-inspired regression, here Firefly in combination with fuzzy logic, which could provide higher correlation coefficient versus old techniques, is used. Overall, by employing mentioned techniques, more efficient and precise results returned in comparison with other methods. However, due to using optimization algorithm, runtime is sacrificed. Using more related business and management datasets plus comparing the proposed system with deep learned feature selection and regression method is of future work. For this research, a system with Core i7 CPU is used, so it is suggested to run the proposed system on over 5,000 iterations and more than 50 population, as optimization algorithm demand more hardware resource. The proposed system could be used as a decent tool for resource allocation in businesses and management applications, which number of DMU are so high. Here we can see some of the references which are used in this experiment, which are 26 of them. And thank you so much for your attention.